Hello everyone, welcome back on this channel. Now I am starting the next remaining part of basic, that is function. First we write here y is equal to f of x. It means y is dependent quantity, it depends on x, and x is independent quantity, where y and x are variable quantity which is vary with respect to x. It means if x varies, then y also varies. Now take an example of living world, such as a football match. In this case, a footballer hit the football. The direction and motion of the football depend on hitter. It means the football hitter hit in any direction, they goes in that direction. So similarly, in case of function, if x varies or x may be varies with a small quantities, then y also varies with a small quantities. So it is fully dependent on x. Now again, in case of footballer, the direction of hitting don't know the football. Same cases, in case of x, they don't know how much quantity changes or when changes. So this one is dependent on x. Now this part is completed. Another one is differential. It means differentiation. Difference means subtraction. In this case, we study about difference of variable quantity, and as we know that the difference is final values minus initial values of given quantities. The difference may be positive, negative or zero. It depends on given quantities. Now next one is differential coefficient. For this we take y is a function of x. Now if x is changes with extremely small quantities, that is del x, or maybe changes by x to del x. Similarly, if x changes, then y changes, as already I am saying in function. So y also changes by del y. Next one is the difference in x, final minus initial. So right here x plus del x minus x, we got del x. Similarly in y we got del y. It means y plus del y minus y cancel out and we got del y. Now take the ratio of 2. If we take ratios of 2, we write here del y upon del x. This one is our basic things. Next, if next case, if x changes by a small amount, that is del x. This one is extremely small, so take del x tends to, how we read it, now understand, del x tends to 0. This one is a reading habit. Del x tends to 0. Then y also changes, as we studied in function. So the ratio of two differences, it means del y del x. If del x changes to 0, then we write here, this one is called limit. limit. So right here limit del x tends to 0 del y upon del x, that is dy upon dx. So we write here d of dx, this one is called differential operator, and here is y. dy dx is reading at differential coefficient of y with respect to x or differentiation of y with respect to x. The two types we read it. Number one is differential coefficient of y with respect to x or differentiation of y with respect to x. This one is in habitual action. So we also study differentiation of y with respect to x. Now this term, that is dy dx, it means differentiation of y with respect to x. We write here limit del x tends to 0 del y upon del x. Now putting the value of del y, this one is change in x or minus x. It means in function form, because y is equal to, as we know that f of x, so put here f of del x minus fx upon del x. This one is the dy dx values. This one is very important and also asked in so many times, so always remember. Next one is geometrical interpretation. In this case we make a curve and after that we got the value of this one. Write like this: dy dx, that is slope of curve, it is called slope of curve, and it is represented by tan theta. Now as we know that dy dx is limit del x tends to 0 del y upon del x is equal to tan theta. This del is another form, it is also a small del, that is called, this one is also del and this one is also del. This one call for partial differentiation and this one call for small changes, and finally we write here d for differentiation. All these are three types. This is called del operator. Next one is theorem of differentiation. It means if by taking a c, then putting the value in differentiation, we got c is a constant differentiation means 0. Next one is x to s to the power n, y is equal to x raised to the power n. In this case we subtracted after taking n as a multiple and x raised to the power n minus 1. Now the next one is y is equal to u raised to the power n, where u is a function of x. We write here like this: dy dx is equal to d un upon dx is equal to, first differentiate this one, then taking du upon dx, this one is a function of x, this one representing, and here is the proper solution. Now in case constant term is in multiplication, then we write here d into differentiation of cu, then c is a constant and then differentiating u. Next one is in additive forms, then we write y is equal to u plus minus v plus minus w, u v w, all are function of x. Then be separating all y differentiation, write like this: d of dx, it means differentiation of u plus minus differentiation of v, differentiation plus minus differentiation of w. Take an example of this one. Now here is example: 3x raised to the power 4 minus 7x raised to the power 2 plus 5x plus 9. This one is a constant, so 0 after differentiation. Now in this case if we differentiate, as we write here, if all taken together, then separating by all of them by differentiation. So right here d of dx 3x to power 4 minus d of dx 7x to power 2 plus d of dx 5x d of dx 9. Generally it is a form of constant and variable, so constant term taking outside. So right here 3 d of dx x raised to power 4 minus similarly 7 d of dx x raised to power 2 plus 5 d of dx dx x plus 0, constant differentiation of constant is 0, so right here 0. The next one is after solving we got it 12x to power 3 minus 14x plus 5, this one is our answer. Similarly in case of this one, here is a root x minus 1 upon root x raised to the power 3. It is a form of a minus b whole cube. It means a cube minus b cube minus 3ab a minus b. So break down on this basis. After that you got like this, under root 3x power 3 minus 1 upon root x raised to power 3. So and 3 root x is cancel out and then solving on this one. So right here under root x raised to the power 1 upon 2, then 1 upon x raised to the power 2, this is a root values. So taking if upper side here, when we write here minus, after solving we got 3 by 2 root x 3 by 2 x raised to power 5 by 2 minus 1 upon 2 root x plus 1 by 2 x raised to power 3 by 2. This one coming, as we know that d of dx root x is equal to 1 by root x upon 2. So this one our answer. Finally we got like this, it is our answer. Next it is a form of multiplication. In case of multiplication, when differentiate, we always remember first constant second differentiation, then in case then plus second constant first differentiation, right? Like 1221 CD, it means constant differentiation, constant differentiation. Always remember in case of multiplication 1221, it means first constant second differentiation plus second constant first differentiation. In case of division we write like dn and d, it means denominator and numerator. Here is a numerator, this one is a denominator. So right here d upon dx u upon v, in case second constant taking like this, second constant first differentiation minus first constant second differentiation upon second square. In case of denominator numerator, in case of division it should be reversed. Here is a 21 12. In case of multiplication 12 21, multiplication first, thereafter division. So always remember like this, denominator constant, numerator differentiation, numerator constant, differentiation denominator, then denominator square. These all are from differentiation, it means the part of function. Now the next part is taking few differential formulas. After solving you got it like this, differentiation of sin x we got cos x, differentiation of cos x minus sin x, tan x, sec square x, cot x minus cosec square x, sec x into tan x, cos x minus cosec x into tan x, sin u, then cos u du upon dx, cos u, then minus sin u and du upon dx, tan u sec square x du upon dx. And the next one is, this one is very important, so always remember sin ax plus b, then here is a constant term a with variable x. So a is outside taking, and this one is separately constant, so this one is 0. So write like this: a cos ax plus b. Similarly, in case of cos, minus a sin ax plus b. The next one is a logarithmic form or exponential form. Now I write here log of x base a. Here is a base a. Now this one is 1 over x log e base a. In case log e and base e, then this value is 1. So always remember d of dx log of x base e. Then we write 1 upon x log of e upon e. This one is a 1, so write here 1 upon x. Similarly, in case of log of u base e, 1 upon u d of u upon dx. In case of exponential power, it means e raised to the power x. Then we write here ex log e cancel out this, it means 1 e raised to the power x. Similarly, in case of u, eu d u upon dx. Next one, a raised to the power x, then a raised to the power x log a base e. And the last one is chain rule. This one is very important. In this case, we first understand how we got it. Maybe on the ratio, maybe on multiplication, it depends on situation. I am taking here for the ratio, it means division method. First, here is given x is equal to t raised to power 2 by 2at. Here is x is a function of t, y is a function of t, but we want dy upon dx. So first solve, it means differentiate x with respect to t, and then we got 2at. Similarly, differentiate y with respect to t, we got 2a. Now divide, it means dy dx. As we write, I have an answer to dy upon dt. Similarly, write dx upon dt, because this t cancel out. After solving it, we write here dy upon dt and dt upon dx. We got 2a into 1 upon 2at, and the final answer is dy by dx equal to 1 upon t. In this case, this one and this one cancel out, so we got dy upon dx, but we have the values of this one and we have the values of this one, so put here. And the last one is few questions for you to solve in your home, and all these questions solved by you. Here is one answer given to you: log under root 1 plus tan x. Here is a tan x and 1 minus tan x. Answer is 1 plus tan square x, 1 minus tan x. 1 plus tan square x upon 1 minus tan square x. You solve it, and the next part is integration. I hope you enjoying it a lot. Thank you.